So last video, I believe I promised that we'd dive a little bit more into ladder logic, and in particular the classic start-stop ladder logic circuit. And so now we get to dive into a topic that people often get wrong and confused and everything else. So here's me going to take my stab at it and, hello, welcome to Chaos and Controls, the show where we talk about modern devices, technologies, and techniques for automating your home, business, or life. I'm your host, the Automation Doctor. I've already discussed a little bit about what we're going to talk for today, so I guess I'm stepping over myself, but you will recall from last time that the classic and quintessential start-stop circuit looks something like this, where I have M1 on a relay, the status coming back from M1, my start signal, and my stop signal. And I'm going to go ahead and say that I'm saying stop and start signals because one of the things that people often get confused with these is actually the buttons and how they go in. And so let's go ahead and talk a little bit about what these different instructions are. The most quintessential, the most fundamental, the most common logic element that you will ever find in ladder logic is this symbol here, sometimes denoted as an X, I, C. I think I got that right. In other words, examine if closed. And so an examine if closed is basically says that we are going to allow power to flow from this side to this side if this signal is closed. Now, I keep saying signal and not button because there's all sorts of different buttons in the world that you can have. Imagine I have a circuit coming along, and then I have a push button that looks something like this. And now let's imagine that I have spring force that is going that way. And so, in other words, the button is normally making contact along here, and so it can normally flow until I press the button. Subsequently, we can also have a button that looks something like this, with spring force pushing also that way. And so normally I cannot conduct going across this until I press this button down. And functionally, we can use either of these for our stop, our start, our statuses, or whatever. And all it would mean is that if this is my I/O over here, for this guy that is normally closed, another word for that would be tied high, I would just say that if this is true, I can't even spell true, I really am an engineer, then I'm going to map that to stop equals false. Or, if this is, we'll call this B1, then my stop condition equals B1 not. And of course, if it's down here, I just simply map, if this is B2, then I could say B2 is equal to start. Or stop, or whatever other button that I want to put in there. The hardware that I use, I just have to know what kind of signals I expect coming into the controller, and then I can just map them to these signals. And by doing that, I allow myself to maintain the same logic coming in. And subsequently, we should also talk about, for M1 going out, maybe the motor starts off of a 0 signal, or maybe it starts off of a 1 signal. All I need to do is take my M1 status, and then I'm going to have some sort of an output block, and I either need to just set it equal to that, or M1 not is equal to that. Simple logic inversion, and then I can isolate my physical inputs from my physical outputs, and then I can use the same logic on the software side. I know we've glossed over a lot of details here. People get confused all the time. Don't panic if you're not following along. It's okay. You'll get used to it after you've done a few examples in the field, online, what have you. Yeah, I'll be honest, I have completely lost myself, but we're still filming. Symbol that we want to talk about. If this is an examine if closed bit, is an XIO, or in other words, an examine if open bit. And it's just the opposite. We are looking for if we do not have signal coming here. And so, logically, looking at this, it's better to think of having the slash as a not condition and the regular XIC as a normal yes condition. And so that is why I can say if I do not have my stop signal, and I do have my start signal, or I do have my status feedback from the motor, go ahead and energize the motor output. It doesn't matter what kind of buttons I have coming in, as long as I've accounted and mapped them appropriately. It doesn't matter what the motor is looking for to start, as long as I've mapped it appropriately. The physical logic, that was bad. The digital logic remains the same.